The average rate of change, or the ARC as we're going to abbreviate it, measures it's defined as the slope of the secant line, but what it's really measuring is, remember, slopes are changes in y over change in x. So you will be given an interval to check the average rate of change over, and we calculate the average rate of change by taking the change in the y values of those 2 points divided by the change in the x values. Notice the interval is written a to b, so this is how you would read it on the x-axis, from left to right, right? So this number is on the left, this number is on the right, but notice when we're measuring the change, we're kind of doing final minus initial, so the order here appears to switch when we're calculating it out by hand. So let's look at an example of how we calculate the ARC. So we want to calculate the average rate of change for the following graph along these intervals. So first, let's look at -5 to -3. So first I need to figure out what f of -3 is. So on my graph, I'm going to come over here. Here's -3, and the y value is at 0. Then I'm going to subtract f of -5. -5 is also at 0. And that will be over -3 minus a -5. So I actually get 0 over 2, which is in fact 0. For the interval -2 to -1, well, I do b first. So at -1, the y value is 1. At -2, the y value is 2. And then I divide that by -1 minus a -2. So the numerator is -1. The denominator is +1. So the average rate of change is -1. From the interval from 1 to 2, well, f of 2 is 3. F of 1 is also 3. And then we'll divide that by 2 minus 1. So the numerator is 0, the denominator is 1, and so the average rate of change is 0. And this kind of makes sense here and here that we got zeros out because these are horizontal lines. So that means the slope between these 2 points is just in fact 0, right? And the slope between these 2 points is 0. However, if we look at -2 to -1, what we're actually calculating is the slope of this segment right here. And if we actually look at rise over run, we can actually see that the slope of that piece of the graph is in fact -1. Now, we're going to use the average rate of change dealing with a lot of data sets. So we're going to figure out in a little bit, we're going to see how we actually calculate the ARC in our calculators given a set of data. But first, before we can even deal with that, we need to know, well, how do we interpret the average rate of change? So I've made a table for you, and I want to make sure we're reading this table correctly. So there's 2 things you look at. You look at the sign of the number, whether it's positive or negative. Then you look at the magnitude of the number, meaning the value of the number. So we ignore the sign for this piece, and we want to know, are the numbers getting smaller or are the numbers getting bigger? So the way we read this, if the sign of the ARC is positive, then the graph is increasing. So we see in these 2, right? Positive, positive, increasing, increasing. When the sign is negative, the graph is decreasing, right? So the graph is rising, the graph is falling. If the values are getting larger, we say the graph is concave up. If the values are getting smaller, we say the graph is concave down, right? So here, increasing means concave up, decreasing means concave down. So let's look at a table of values and actually see how to interpret this. So I've given you, it's 2 columns here, right? These are the XY values, and these are the ARCs between this point and its next point, right? This point and its next point. So that's why you'll always see a little dash line at the end, because you don't have another point to compare this to. So when we look at 4 to 5, right, that's where this ARC comes from. So in your packet, there's a slight typo here. This last interval says -2 to 5. It should say +2 to 5. So let's look at how we read our ARCs and use our table above to interpret the behavior of the graph along these intervals. So once again, these represent the x values. So -4 to -2 is right here, right? These first 3 rows. So I'm just going to highlight this, right? So the first thing I want to check for is the sign of the numbers of my ARC. So these are all positive. So we have a positive sign, right? That means the graph is increasing. However, what's happening to the value of the numbers? Well, it goes from 35 down to 15, down to 1. So since the numbers are decreasing in value, that means the graph is concave down. Sorry, down. There we go. The graph is concave down. So we would conclude that this graph is increasing and concave down. So it might look something like that, right? It's going up, but it's curving down as it goes up. So if we look at -1 to 1, so I'm going to use a different color here. So -1 to 1, we're looking at this section of the table. So the first part of this is not too bad. All the numbers are negative. So if the numbers are negative, that means the graph is decreasing, right? The values are falling. However, let's look at what's happening to these numbers. Well, it goes from 7 to 9, that's getting bigger, but then it goes from 9 to 5, and that's getting smaller. So what's happening is from 7 to 9, so on the interval from -1 to 0, these numbers are increasing, which means the graph is concave up. However, from 0 to 1, the numbers go from 9 to 5. They're decreasing, which means the graph is concave down. So for this particular interval, the graph is concave up part of the way, the graph is concave down part of the way. So this is telling us there's a change in concavity on that interval. So we know that there's actually an inflection point on that interval. But the graph is decreasing the whole time. So the graph is going from concave up to concave down, and there's an inflection point at some point, but it's falling the whole way. The third interval we want to look at is +2 to 5. So we're looking here at these values. So the first thing I check for is the sign, and these numbers are positive, so that means the graph is increasing. But then we look at the numbers. They go from 5 to 21 to 43, so the value of the numbers are getting bigger, and that means the graph is concave up. So this graph is increasing and concave up, so it probably looks something like this. So are there any maxima or minima, and if so, what interval do they exist? So we know that turning points are maxima and minimas, right? And turning points occur when a graph goes from increasing to decreasing or decreasing to increasing. So we want to look for changes in the sign of the ARC. So if we scan down this graph, the ARC is positive, and then it suddenly becomes negative. And that happens on the interval from -2 to -1. So this graph goes from increasing, that's what positive ARCs mean, to decreasing. And so if we actually look at what that might look like, the graph went from increasing to decreasing, so that is actually describing a maximum. Then the ARCs stay negative, until you get to here, right? They go from -5 to +5. So that occurs between 1 and 2 on the x values. So on the interval from 1 to 2, the graph goes from decreasing to increasing. So it's going to go down and then start going up again. So that means there is a minimum in that interval. And we already identified that we found an inflection point, right, up here in this interval. So this question didn't ask about inflection points, but this is how we can identify specific attributes of graphs by just simply analyzing its average rate of change.